Alright, so probably against better judgment, I'm going to make a video at midnight. Hope you're all doing well. We're going to talk about the periodic table and periodic trends, and a lot of this stuff I've brought up in the past, and now I'm just going to do it for real, I guess. The periodic table is broken up in many ways, and I keep calling it the greatest cheat sheet. And we have this little staircase here that separates the metals from the non-metals. We have names of groups, the alkali metals, the alkaline earth metals. These are the transition metals. These are the rare earth elements and halogens and noble gases. So we're just going to make this all official, and I'll finally actually test you on this, I guess. Periods. So periods go, they're the rows of the periodic table, and they tell you that all the elements have the same outer shell filling up. So, and we should have figured this out earlier, but the first shell fills up in the first period. The second shell is filling up in the second period, because this is, you remember that 1s2 is filling up here. The 1s is filling up between hydrogen and helium. And then the 2s is filling up here. The 2p is filling up here. So that's the outermost shell. So that's all periods are. And that's not hard. You can handle that. All right. Valence electrons are the outermost electrons, and those are the electrons that are first interacted as another atom comes and approaches. As two atoms approach each other, it's the valence electrons that are going to interact. And because they interact, that's the reason that an element will react in a certain way, and it's why elements with the same valence electrons, the same number, will behave in similar manners. And that's why we've put them in groups based on basically their valence electrons. So everything in the 1A group, this alkali metal family, has one valence electron, and everything in this 2A, the alkali earth metal, anyway, I think that's alkaline earth, but anyway, that's two valence electrons. All the transition metals basically will have two valence electrons because you're filling up the D from the previous shell. So when you fill up the 4s, you're then filling up the 3D. So the outermost electrons are still the 4s. So most of these will have two. There's some, that's midnight talking. There's some exceptions, but we're not really going to get into that. All right. So the 3A, the boron family, has 3 valence electrons. The carbon family has 4 valence electrons. The nitrogen family has 5, 6 for the oxygen family, 7 for the halogen, and 8 for the noble gases. And you recall that the noble gases are sort of where everything wants to be. That's where the stable things are. The full S and P subshells are the way to go for stability. All right. So noble gas configuration, if you're going to use any element, you first of all remember that there's blocks, and this is a good review for the midterm, which is part of the reason I'm doing it. The S block is here, and that's because S holds 2 electrons, and there's always 2 things here. Keep in mind that helium in this case should be over here for the S block to be complete, but it makes more sense to be here with the noble gases for other reasons. The P block, which holds 6 electrons, is here. This is the row you're in, P, so that is the 2p because you're period 2, and this is 3p because you're period 3. This would be 4p. And then the D subshell here is the row you're in minus 1. So this is the 3D because it's in row 4, and 4 minus 1 is 3. And that's why all of these pretty much have 2 valence electrons, because they fill up the 4s first before they fill in the 3D. And then the F, which we didn't really talk about, but maybe now you'll feel a little more comfortable exploring it a little bit. So the lanthanides here go here. This 57 to 70 fit in here, where this little star is. And the acetonide series, 89 to 102, fit in here. And basically, it's the row you're in minus 2. So this here, if you were filling in like number 60, since that would be in row 6, you would be filling in the 6s and then the 4f. And that would be 4f, 1, 2, 3, 4. All right. So the way we do this, noble gases, for noble gas configuration, you take the noble gas from the previous period, you start with the period number in S, and you move your way to the element of interest. So for example, neon, here's neon. So neon is just quite simply 1s2, 2s, right? 1s2, 2s2, and then 2, because we're in row 2, P, 1, 2, 3, 4, 5, 6. So 1s2, 2s2, 2p6. It has a full valence. The 2 shell, the 2 energy level is full with eight electrons. Chlorine, if we were going to do chlorine, so chlorine is here. We were going to take the valence, the noble gas from the previous row, so that's neon. So we're going to say it's neon. Everything neon is plus, we're in row 3, so 3s2, and then row 3, 3p, 1, 2, 3, 4, 5. So chlorine is neon, 3s2, 3p5. If we look at selenium, here's selenium. So selenium is everything argon is, and argon is a noble gas right here. So to get to 34, we got to get through 18 first. So we'll say everything 18 is plus, now we start with the 4s, 4s2. We go down one from the period. So this is 3d, and we go all the way across. So that's 3d10. And then we go back to the number of the period 4, and it's 4p, 1, 2, 3, 4. So selenium is argon, 4s2, 3d10, 4p4. Palladium is right here, number 46. So the previous noble gas is krypton, number 36. So it's everything krypton is, plus now we're in the row 5, period 5. So it's 5s2, and then 5d, or I'm sorry, 4d, because it's the row -1. So it's 4d, and it's 1, 2, 3, 4, 5, 6, 7, 8. And I hope that's true. I should look that up. But yeah, I'm pretty sure that's true. So it's krypton, 5s2, 48, and then radon. If you look at radon, radon's over here. That's everything xenon is, plus the 6s2, the 4f14 to get to 70, and then the 5d10, and the 6p, 1, 2, 3, 4, 5, 6, 6p6. All right. So hopefully you can do some of those and do some of the table I assigned. And I might as well finish this off. The two main contributors of the periodic table, the people who set it up, one was Dmitry Mendeleev, a Russian scientist. He came up with the first periodic table. He came up with the idea of organizing everything by atomic mass, because we always knew that certain elements reacted the same as other elements, but we didn't really know how to organize things. And if you really think about what a task that must have been, trying to put all those, it's a giant puzzle, and they're trying to put it together. So the cool thing about Mendeleev is he actually left blank spaces for the undiscovered elements. So if you look here, he knew these two elements were yet to be discovered, even though they weren't, because he knew the pattern and he knew these things would fall in right here. And it turns out to be based on the mass, germanium, and he was looking at gallium and germanium. He knew between zinc and arsenic there were two things. And so let's look here. Between zinc and arsenic, there were two things that he figured out were going to come. So that was good work by him. All right. Moseley was the one who figured out to organize by atomic number, because if you actually look at some of these, somewhere down here, yeah, iodine is actually lighter than tellurium. So in Mendeleev's periodic table, iodine would have come. Well, I guess he figured that out with the question mark. He knew iodine reacted like bromine and chlorine and stuff, but he didn't understand why it was lighter, even though he knew it was. So there you go. He was smarter than I realized. So Moseley did that, and that's that. So hopefully that helps. Help me sleep. So that's good, right? And I will talk to you all tomorrow, which is today, I guess.